All right, so first one we're going to do here with Excel is on airport traffic. So we've seen, I think, the same example with the different, doing something different. And here we're looking at the annual number of passengers going through Hartsfield-Jackson Atlanta International Airport between 2000 and 2008. And it can be modeled by this equation, okay, this function. And where output is measured in million passengers, and T is the number of years since 2000. And we're supposed to numerically estimate p prime of 6, so do all those limits like we just did, and it's to the nearest 1,000 passengers, and we're supposed to then interpret the result. And then on B, we're supposed to calculate the percent rate of change of p at t equals 6 and interpret that result. Okay, so let's go to Excel. And because it's going to take a long time to type all this in, I went ahead and I did this, although it looks like I did the first two also. I went ahead and did the first two by Excel to kind of show you how that was. And so, what we do, remember this, we just did these, both of this 1 and 2 here were on by hand. And so I had the 1.9, 1.99 all the way up to that. And then I did the 2 to the 1.9. So I just took 2 arrow up A2, which is this position. And then my slope was the f of x minus f of a over x minus a. And so it was 2 to the second, because that's what we're looking for, minus 2 to the 1.9 divided by 2 minus 1.9, and that gives me the answer. And so when you do this, you can type this one in and this one in, and then you just control D down and you get the rest of them. And then once you get this, you can copy and then paste it on the ones below here, and it changes. And because what we're doing is when you copy and paste and do copy down, these values change. So it takes it to the same one, to the 2 positions to the left. And here it's the one that's 1 position to the left here, if you think about that. And so it does, Excel does really nice things like that. And then it also does something if you click out. And so what we did is we ended up with this, and it's out to a lot more decimal places than I even wrote down all of these. And so the limit of the slopes, I didn't write what it was because I can't write that with typing, was 2.8. So we rounded to the nearest tenth, and we got 2.8. Here we got again 2.8 from the right. This one, when we did from 5 to the left and right, we got the basically 1. Now see here, we go out further and further, and it was 909090, and then 99991. So you can see, different numbers here. If we would have just did it to the 4 decimal places, it would have been 111 all the way down. Okay, but that's doing those first two via Excel as well to kind of show you what we do. And here all we did was we took 5 times ln of A2, which is the 4.9. Here we took 5 times ln of 5, because that's what we're estimating at, minus this value, the f of x, divided by the 5 minus the 4.9. And then it does all the calculations for you, and we get the 1.00. All right, now we're on to the airport one. And so with the airport one, this was our function they gave us, the negative 0.102 t cubed plus 1.39 t squared minus 3.29 times t plus 79.25, okay? And what they wanted us to do was at t for 6, okay? And so what we're going to do is we're going to have to come from the left. So 6 from the left, which will give us 5.9. And then we just keep typing up more 9s in there. And the nice thing is this, if we get down here and it's not been going the same for several in a row, we can put a couple more rows here and do more calculations, because those are going to copy down. We don't have to worry about typing these in, because if I decided to put in here 5 point, and then we have 1, 2, 3, 4, 5, 6, 7. I don't know how many I need in there. That automatically puts in the next one down. So we don't even have to type it in. It just keeps going down, and we don't have to worry about it. But if we'll have to make that a little bit bigger to see it. And it looks like I just added the one more, so that's good. And you could add more that way too with the below here. Let's just copy this one down instead. That way I don't have to think about how many zeros I'm. Oh, and then I can just add a 0 here, enter. And this time I had copied down further, so I need to control D, and that will give me the values that I need, but it doesn't look like it controlled D very well here. Oh well, what did I do different? 20. Anyway, so that it's going to work the same, but something I've just typed something wrong here. All right, let's go. I think I typed something wrong in there, so there we go. And then we'll get rid of that row too. There we go. Now we're back to the original data. All right. So in this one, we have this function. And so we have to type that into our cell here, and we want to use this as our value. So we're just going to replace our t with an a2, which is, we can, as we type it along, we can put equals negative 0.102 times, then click over here into a2, and then raise it to the third power, plus the 1.39 times a2 to the second power, minus 3.29 times A2, and then plus 79.25. And then when you hit enter, we get the value. Now the slope, remember, is just the f of x, but using the actual value we're looking at 6. So we have the same thing, but now it's at 6, and then 6, and 6. And then we can just subtract off that b2 because that's what f of x is. And then we're dividing by our 6 minus our a2, which is our, one digit to the left. And so that's going to be that. And then when we go to the next one, what happens is, what am I doing here? All right. What happens when we go to the next one? Then we have the A3, so it's going to be 5.99, so it's going to be dividing by the 0.01, and we're going to use all the rest of the stuff here. This is with the 5.99 in place of the 5.9 and the one above it, and we just keep going down. And what we see is it goes to 2.37400000154 at the end, but we're only going to, on this one, we're going to the thousandths, so we're going to have 2.374. We do the same thing here. Now we're, instead of the 5.9, we do the 6.1. And so when we get that, that looks like we have 2.374 as well. And so both of those going from left or right, we get that value. Now, I think let's go ahead and let's copy this so we can take it and put it into our screen, or at least we'll try to. And we'll go back to here. Now, I think we'll probably have to shrink it down. All right. It's going to shrink down. And so I'm going to paste those over here on this page, or at least I'm going to attempt to. And it's not going to let me do it. Oh, well. So since we're now out of the big screen, let's just copy this. And so we can just highlight what we're looking for. That way we have our data on the PowerPoint. And so now if we paste that, hopefully it'll work now. All right, so now we've got our data. And so now let's go back to the first part. It says numerically estimate P6 to the nearest 1,000 passengers and interpret the data. All right, so what we can say is A, let's get our writing utensil. That'll work. For A, we get 2.374 is going to be our P6. So P prime of 6 equals 2.374. And that's all it's asking for. What is that derivative? And so that's what it is. And so without units or anything, that's going to be our derivative. Now it says interpret that. Well, now what we have to do is we have to write what it says. So at the end of now 6, so it was 2006, the number of passengers going through the Atlanta airport, I'm shortening it, was increasing, and it was by about 2.37. Oh, actually, now this is in millions, and so we want it in thousands. So it's going to be, we need to write that in thousands instead. So that was 23E74,000 people, and that's going to be per year. Okay. And so if we go back here, it's millions of passengers per year, and we wanted it in per thousands. So we had to multiply that by 1,000, and then we had to go and convert it from millions down to thousands. So we had to do two unit changes there. Okay. All right, so what's the next one say? Calculate the percent rate of change of P at T equals 6 and interpret the results. All right. Well, let's go ahead and write that one here. So for B, the percent rock was going to be equal to, now remember, it's just our P prime of 6 over what the P of 6 was, and then times 100%. And so if we plug all our values in there, what was that? That was going to be, now I don't have my, we'll need to go back here. Let's see, because I don't remember what this value was. $87.518. So we have 2 point, 374 divided by 87.518 times 100, and we get 2.72. So if we're going to write all this stuff down, which I guess I should, we get the 2.374 divided by our 87.518 times 100%. And that's going to be equal to, and it's going to, again, it's approximately, I should always put approximately 2.713% per year. Okay, so same sentence as the last one, but it's increasing by 2.713% per year. So, you know, or let's do that, or by 2.713% per year. Okay. So we kept it as the people, and then we also converted it to the percent rock, and so we can have both of them, and that way we don't have to write those two sentences. It's the same thing, except we're just saying it's or this or that, so it works either way. Okay, and again, we just used Excel to plug all this in, get our values, which we just copied and pasted in here, except for the 87.518, which we had to go back and get. And so we'll make sure to get that for the next one. And so then we can find our percent rock. All right. Let's stop there and come back.